Bone growth and repair. Bone is a living tissue. Yesterday we talked about why bone does not look living. What was it you said? The hard, stony appearance of it. So it doesn't look living, but it actually is. So let's look at the cells that make up the tissue of bone. The first cell is osteoprogenitor cell. Oste meaning bone, pro meaning beginning, gen, produce. So we have bone beginning basically production. So that's almost giving you the definition of the osteoprogenitor cell. This is an unspecialized cell. It's found in the inner portion of the periosteum, the endosteum, and the central canal. So let's take a look at that. So where is it located? Osteoprogenitor cells are located up inside, underneath the lining of the periosteum, the lining of the endosteum, which is then the medullary canal or the central canal. And so they're near or on free surfaces. Now, these are going to transform into osteoblasts. So as they divide, as they go through mitosis, then they specialize. They become osteoblasts. Osteoblasts, let's look at the root words and the suffix of that. Oste again is bone. What does blast mean? Think of your medical terminology. Blast means bud or growing. So we have bone growing. So these are bone-forming cells or bone-growing cells. They also secrete their own matrix. What might the matrix be composed of? Think about the different tissues and different kinds of matrix we looked at when we looked at the tissues. We're going to have fibrinogen, we'll have fibroblasts, and then protein. Once the osteoblasts have secreted the matrix and secreted enough matrix that it actually surrounds itself, then it becomes an osteocyte. So let's look and see what the root words and the suffix for osteocytes might be for medical terminology. Oste again meaning bone, and cytes. What does cytes mean? Cell. Now we have bone cell. So osteocytes are a mature bone that comes from the osteoblast. So let's look at osteoclasts. Remember, these are all the different kinds of cells that are in bone tissue that we're looking at specifically. Oste, bone. Clast is not in your medical terminology that I have listed for you, but clast means to break down, the bone breaking down. Now this cell performs bone reabsorption and the redepositing of calcium and phosphate. So it really is an important cell, and we'll see in a little bit as to why. So let's talk about bone development. Ossification. Ossification is the actual formation of bone during the embryonic development. There are two kinds of ossification. Intermembranous ossification. Intermembranous develops between sheets of very fibrous connective tissue, and this would be the skull. Then we have endochondral ossification. This is the initial hyaline cartilage, where you have the initial hyaline cartilage, and it's replaced by bone. So initially, you have the breakdown in the center of the diaphysis, where the periosteum starts to be covered. I thought it might be helpful to actually see the diagram here as I'm talking about ossification. So initially, in the first step, we have the breakdown in the center of the diaphysis, right in this area here. So, embryological formation of a baby. Initially, the bones are all cartilage. First step of the formation of bone is you start actually having a breakdown in the diaphysis and the periosteum. starts to form and develop. Osteoblasts are going to start laying down spongy bone. This is called primary ossification. If I can write that. No, not going to let me right now. It's called primary ossification. So primary ossification, again, is where osteoblasts are going to invade the area that's starting to break down in the cartilage and going to actually lay down spongy bone. Where do the osteoblasts come from? Osteoprogenitor cells that are in the periosteum. Other osteoblasts begin to lay down compact bone under the periosteum also. The compact bone will start thickening. So the compact bone starts to thicken, and osteoclasts will then start breaking down the spongy bone that was formed. So when the spongy bone starts being broken down by the osteoclast, this is where the medullary cavity comes about. So all of this is primary ossification, and this occurs before birth. Now, after birth, in secondary ossification, we have a continuation of that. The epiphysis and the long bone of the diaphysis continue to grow, and spongy bone forms up in the epiphysis, but it doesn't break down. So in secondary ossification, you will have spongy bone being formed in the epiphysis, but yet it is not broken down again. We have the epiphyseal seal, or the epiphyseal plate. This is where the cartilage separates primary and secondary ossification centers. So our primary ossification center, where we originally had the cartilage and we had spongy bone form, compact bone formed around it, and then osteoclasts came in and broke down the spongy bone. Primary ossification. Secondary ossification occurs in the epiphyseal ends, the distal and proximal epiphyseal areas. And this is where spongy bone forms, but is not broken down. So the epiphyseal plate is what separates these two centers. Limbs will keep increasing in length and width as long as this plate is present. What regulates it? The presence of hormones. Once the epiphyseal plate is completely gone, then you end up having mature bone, and that's as large or as long and as wide as the bone is going to become. I'm going to show up the notes so that way you get a chance to read back over them or write them down. Just pause them where you need to. The next video will go over bone remodeling.